Hello and welcome. In this video we will discuss the section formula. The section formula helps us to find the coordinates of a point P that divides a line segment in a plane. It is also helpful to find the ratio in which to find the coordinates of a point that divides the line segment in a given ratio. For instance, let AB be a line segment if a point P lies on the line joining AB, then the point P is said to divide the line segment internally. Internal division, because the point P is dividing the line segment in the ratio AP is to PB. And if the point P lies on the extended line AB, then P is said to divide the line segment AB externally. If P lies outside of the line segment AB, then it is said to divide the line segment AB externally. In the ratio minus AP is to PB. Now the coordinates of the point P, which divide the line segment joining AB, is given by a formula. Let the coordinates of A be x1, y1, and the coordinates of B be x2 and y2, and let P divides the line joining AB in the ratio L is to M. That part is L, and let this part be M. So the point P is dividing AB in the ratio L is to M. Then the coordinates of point P, x comma y, are given by Lx2 plus mx1 divided by L plus M, comma Ly2 plus my1 divided by L plus M. So if we are given a ratio in which a point divides a line segment AB, then we can find the coordinates of the point P using this formula: Lx2 plus mx1 divided by L plus M, and Ly2 plus my1 divided by L plus M. Also, the points which divide the line segment in the ratio in the ratio 1:2 or 2:1 are called the points of trisection. Now let us take an example and use the formula we discussed to find the coordinates of the point which divide the line segment joining -1, 2 and 4, -5, and the ratio of 3:2. Here the ratio L:/M is 3:2, and the coordinates of the line segment joining 1 and 2, -1 and 2, and 4, -5. Let these coordinates be x1, y1, x2, y2, and L and M are 3:2. Now using the formula P x comma y, Lx2 plus M divided by mx1 divided by L plus M, and Ly2 plus My1 divided by L plus M. Let us use this formula and find the coordinates of the point P. L is 3, x2 is 4, plus M is 2, x1 is -1, divided by L plus M is 5, and L y2 is 3 times -5, plus M y1 is 2, divided by L plus M is 5. That gives you 12 minus 2 divided by 5, and -15 plus 4 divided by 5. That gives you 10/5, which is 2, -11/5 is the second coordinate, the y coordinate. So we have the coordinates of a point P that divide the line segment joining -1, 2, 4, and -5 in the ratio 3:2. Let us take another example and find the coordinates of the point that divides the line segment joining 4 and 5 and -3, 4 in the ratio -6:5. Now since the ratio is negative, the point P for instance divides the line segment externally. Since the ratio is negative, the point divides the given line externally. Now we have the coordinates 4, 5, -3, 4 of the line segment, x1, y1, x2, y2, and also the ratio -6:5 L and M. And now we can quickly apply the formula and find the coordinates of the point. Say P x y, Lx2 plus M x1 divided by L plus M, and Ly2 plus M y1 divided by L plus M. Okay, well, let us see. L is negative. -6 times -3 plus M is 5, x1 is 4, L plus M is -6 plus 5, Similarly, negative 6 times y2 is 4 plus m 5 times y1 is 5 divided by negative 6 plus 5. That gives you negative 6 times negative 3, positive 18 plus 20, which is 38, divided by negative 1, comma, negative 24 plus 25. Negative 24 plus 25 is 1 divided by negative 1. So the coordinates are negative 38 and negative 1. So the point P has these coordinates. Let us take another example. Find the ratio in which the point P 2, 1 divides the line segment joining A 1, negative 2 and B 4, 7. Now we have the coordinates, we don't have the ratio. We have to determine the ratio now in this problem. Now let the ratio be lambda is to 1, because we don't know the ratio, because every ratio can be simplified to lambda is to 1. Lambda can be anything, any number, any real number. So we have to determine the ratio given the coordinates of the point. We can use the same formula to determine the ratio and equate the coordinates to the point P, which is 2, 1 that is given. Now the x coordinate of the point would be, because the ratio is L is to M, this one is L and M, you can apply the formula and equate it to the point 2 and 1. x1, y1, x2, y2. Now Lx2 is lambda times 4 plus m, which is 1, x1 is 1 divided by lambda plus 1. Okay, and Ly2 is lambda 7 plus m y1 is 1 times negative 2 divided by lambda plus 1. That is x comma y. So the x coordinate would be 4 lambda plus 1 divided by lambda plus 1, and the y coordinate would be 7 lambda minus 2 divided by lambda plus 1. Now we have the x and y coordinates, which is P 2, 1. We just have to equate one of these coordinates to the given coordinates of the point. Now let us do that. Let's draw a line. The coordinates are given. The x coordinate is 2, so let us equate 2 to the coordinates we got using the formula, which is 4 lambda plus 1 divided by lambda plus 1. That gives you 2 lambda plus 2 equals to 4 lambda plus 1. that gives you 1 equals to 4 lambda minus 2 lambda. I'm just simplifying this. 1 equals to 2 lambda, or lambda equals to 1 over 2, which is 1:2. Since the ratio is 1:2, the point P divides the line segment joining AB internally. So this is internal division, since the ratio is positive. We can either equate the x coordinate or y coordinate, we can get the same result for the ratio. So this is how you find the ratio given the coordinates of a point. Thank you for watching.